Good morning. Thanks for joining us, everybody. Welcome to our next edition of the eLearning presentation. This one is industrial hose assembly, focusing on safety and cradle to grave management. So we want to just give you a wave here, and we're going to go dark and get this going. So it is Wednesday, November 11th. First, I'd like to thank any veterans who might be in attendance for your service. Family members, and anyone else you may know that's a veteran. It's a special day here for sure. So we are going to get moving on this. We got a great group here today joining us all around the US, bunch of different industries. Thank you again. Peerless started in 1914, again, as a general mill supply with an emphasis on our catalog. We've evolved over the time to become an ISO certified company and a trusted source for process components. We operate under 3 different distinct divisions. Our process group, which really focuses our time on the plant environment. We have our Procore team, which works with OEMs and equipment builders with more specifically customer-specific requirements. We have our high-temp fabrication group, again, scientific surfaces, laboratory casework, and high-temperature insulation. We do cut and mold, machine to print. So, presenting today is Austin Smith. He is our application engineer. He spends a lot of his time working on hose specifying, and you can see he's a very miserable person by the picture. So there's Greg Barrell. You'll hear from him a little bit today. Dan Morgan, our continuous improvement manager, and again, me, who's here every week hosting this for you. So again, I mentioned Austin's demeanor, and I went back looking at some different pictures, and no matter where we see him, he's always got that smile on his face. Look, even swinging a hammer, building houses, he's smiling. Even when the camera's not looking, he's smiling. So that is something Austin brings with him every day. So I'm going to turn it over to Dan Morgan, but before, real quickly, don't let his title fool you. He's got a bit of a goofy side to him as well. So I'm going to turn it over to you, Dan.
That's my casual Friday look, if anyone was curious. But thanks, Kev. I'll take over the presentation here real quickly to show you guys just some housekeeping things. Yeah, if this is your first time joining, you got treated to that nice intro. But in front of you, you see this control panel. So just to explain a few things here, you can collapse the control panel with this orange arrow, toggle in and out of full screen mode here. If you need to change any settings of your audios, those are using these drop down arrows. But then I guess the part we want you to pay most attention to is this questions panel right here. So as we're going through the presentation, as Austin's running through, if there's anything that you have a question on, anything that you want some clarity on, or maybe something application specific that you might want to discuss, please feel free to type in a question in this questions panel, and then I will be monitoring that, and then finding moments during the presentation to interject and ask Austin those questions to make sure we get you those answers. So yeah, please do participate as much as possible. And with that, I'm going to turn the control over to Austin, who's going to bring up our presentation. But before he dives into it, I'll just run through quickly the agenda for today to let you guys know what we're running through. So Austin, if you can go to the next slide. Perfect. So yeah, before Austin jumps in, Greg Barrell is actually going to talk for a few minutes and just maybe give a little bit of real world examples of the critical nature of a hose, industrial hose assembly and system, and really just highlight some of the potential for failure there and why it's so critical that safety is considered during all stages of the process. Next, Austin's going to show us the construction. Oh, sorry, if you could just go back. Thanks. Yeah, he's going to show us how a hose is constructed. After that, we're going to walk through some of the criteria and the important characteristics that we need to know and should be considered as we're selecting hoses and building out a hose system. We'll talk a little bit how those components come together during the fabrication process, and then talk about how the fabrication is verified to, again, ensure that safety. After that, Austin will run us through some of the QA considerations that should be made, again, to focus on safety and testing and performance. And then once a hose is constructed, how do you go about properly handling storing it and maintaining it to ensure that longevity and safety through its life cycle. So, all right, Greg, I think you're good to take it away.
Perfect. Thanks, Dan. Appreciate it. All right, what you see here is a hose failure. I was at a chemical plant here locally, and you'll see in the picture that the hose actually pulled away from the fitting, and I was actually in the plant when this happened, and it made an incredible noise just with that pull of the hose away from the fitting. And basically there was a small spill, but luckily there weren't any injuries. But one of the issues was that the process was down. So again, what you're looking at is just the consequence of not having a properly fabricated hose assembly here. And then one other item which could have made things even worse is you'll see there's a wire braid that's actually holding the hose. So if that wasn't in place, that hose would have been flying around. Thanks, Austin. Next, we have a hose in service here. That's as you can see, there really wasn't any preventative maintenance done to this hose, and just by the looks of it, it doesn't look like there's really any hose management program put into place. So you'll see the wear and tear on a hose when there really isn't any preventative maintenance done for hoses. And lastly, Austin's going to play a video here on what would happen if one, the hose isn't connected properly, and two, if you're using a hose that isn't rated to a particular pressure. And I do want to point out that this is not a real person in the video, but it's just done to show you what could happen when a hose is not connected properly. So again, this really stresses the importance of not taking a hose assembly for granted. So, and I know Austin's going to be getting into the nuts and bolts here of the presentation, and take it away, Austin.
All right, thanks, Greg. Well, to start things off here, we're going to start with a quick poll question.
Yes, I'm going to get that launched. Yep. I'll get it launched right now. So yeah, everyone, you should see a question right now up on your screen. So for this, we just want to kind of get a feel for, a sense for, your organization's kind of how you handle your industrial hose system, the management of that, maintenance, and so forth. So this will just help us and kind of tailor some of the things that Austin's going to talk to in the upcoming slides. So I'll just leave this up for another couple of seconds. If you're having trouble clicking on the answers, you may have to get out of full screen mode. That has caused some issues in the past. So if you're unable to make a selection, try doing that first. So yeah, I'll just give us another couple of seconds. Looks like a good portion of you guys have voted so far. All right, I'm gonna get this closed. Okay, it looks like, yeah, about, pretty even distribution across the three selections. So yeah, I guess that's where it leaves us, Austin. We got, about 30% had a program in place, 40% did not, and 30% is maybe. So kind of across the full spectrum there. So thank you for your participation.
Yes, thank you. So going to get started here with just a general overview of what about the basics of industrial hose. Well, I guess we're going to start actually with just hose in general. It is a purpose-built product. Many different industries use hose in many different applications. Each hose is specifically built to handle that application. Obviously, some of those examples include chemical, food and beverage, steam. You'll see for hoses that have, for similar uses, you'll see similar constructions. So you'll have a bunch of chemical hoses. They'll have very similar constructions, but there will be small details that, that help to differentiate one chemical hose from another. But if you compare chemical hose to, say, a steam hose, you'll really see a big difference there. So not very really interchangeable for between uses. And in terms of hose, there are 5 basic types. Industrial hose, which we'll be talking about today. There's corrugated metal hose, which is a metal core with a metal braid on the outside. Fluoropolymer or PTFE. There's composite hose, as well as hydraulic. But as I mentioned today, we're just really going to focus on industrial hose. So for industrial hose, these are just a few of the manufacturers that are out there. You may recognize some of them. Gates and Continental are some of the big players when it comes to industrial hose, rubber, thermoplastic. But we do have some others. This is, for example, A-Flex, Crane Resistive Flex deal just with fluoropolymer hose. We have HoseMaster. They're a manufacturer of corrugated metal hose, and as well as Flexos, who mainly deals with ducting style hose. So what is hose? So NAHAD, which is the National Association for Hose and Accessories Distribution, they define hose as a reinforced flexible conduit used to move materials from one point to another or to transmit energy. It is flexible to accommodate motion, alignment, vibration, thermal expansion and contraction, portability, ease of routing, and ease of installation. So it's a lot of words for something that seems so simple. So what does this actually mean? So when we're talking about industrial hose, you can see a little cross section here in the bottom right. Industrial hose is normally rubber or plastic with some sort of textile fabric or spiraled or braided reinforcement. Typical categories, kind of as I was talking about before, between chemical, food, and beverage, but it's commonly used in air and multi-purpose applications, as well as material handling, bulk handling, petroleum, as well as just general purpose water, suction, and discharge. So a little bit more of a breakdown of what industrial hose is. There's 3 main components. The innermost component is the tube, and that's the element that's going to be in contact with the process media. So you really want to make sure whatever is going to be going through the hose, that the material of the tube is compatible with that media. In the most general terms, the tube is made of some blend of rubber or plastic or fluoropolymer. As we work our way out, we come to the reinforcement, which you can see as the darker ring in this cross section. That's typically built right into the body of the hose. And the main purpose of the reinforcement is to provide the hose with the capability to withstand pressure, vacuum, and any other external forces that the hose may see. You may see for reinforcement a braided or spiraled textile, either plastic or metal helix, which helix will help it with vacuum capabilities, or you may see braided or spiraled wire built right in. And then on the outside we have the cover. That's typically made of some sort of blend of rubber or plastic, depending on what application it's being built for. The cover is meant to protect the reinforcement in the tube from any exterior damage from the environment, whether that be sunlight, abrasion, any oil or acid that may be dripping onto the hose. So I briefly mentioned all the different types of hose in a previous slide, but why would you want to choose industrial hose over the other types of hose, say corrugated metal or composite or fluoropolymer? Well, assuming that industrial hose is right for your application, which we'll dig into a little bit later, compared to the other types of hose, you can definitely have a much more flexible assembly when you use industrial hose. Just based on the method of production, you're able to get much longer continuous lengths. For a metal hose, you may only be able to get at a max 100-foot long assembly made. But with industrial hose, there's air and multi-purpose hoses that are available in 500 to 600-foot continuous lengths if that's what's needed. Along with the ability to produce long lengths, industrial hoses are available in very large inside diameters or large bores. Commonly, 6 to 8 inch is a common large size, but there are some available 10 inches, 12 inches, even much larger, which you're not really going to be able to get with other styles of hose. And with industrial hose, you're able to crimp just about any type of fitting onto the end of it. So if as long as it has a hose shank, it's compatible with your application. There are many different types of fittings out there that'll work with an industrial hose. So we talked about just the hose itself, but now we're going to get into a little bit about what makes up an industrial hose system or an assembly. And this is what's really going to be usable as a deliverable for you to put into your application or your process. So there's 3 main components here. One is the bulk hose. Obviously there's the fitting on the end, but there's also the crimp sleeve that we have here as an attachment method. And based on your application requirements, there are many different types of hoses, attachments, and fittings that are out there to allow you to put this into your application effectively and safely. So how do you determine what hose, attachment method, and fitting you're going to want on the end of the hose? For that, you like to use the acronym of STAMPED, which outlines the information that's required to make sure a quality, effective, safe hose assembly is being placed into your application. So we're gonna just kind of briefly run through these categories. Actually, I don't think it was mentioned before, but if you go back up into your control panel, you'll see there are 2 handouts available. And in either of these handouts, there'll be a much more in-depth breakdown of the STAMPED acronym. So if you have any questions, you can either, like Dan said, reach out in the control panel in the questions area, or there is much more in-depth explanations in the handouts. But for the first letter of STAMPED, it's S for size, and now the size refers to the inside diameter of the assembly, as opposed to piping or tubing, where you're either there's a nominal size or you're basing it on the outside diameter. For a hose, it's sized based on the inside diameter. And when you're speccing out a hose assembly, if you don't have something that's already in place, you're going to want to make sure your inside diameter is large enough to accommodate any high flow rates or flow velocities, if that's important to your process. Obviously, the smaller the hose gets, you may deal with higher flow velocities if you're trying to keep up a high flow rate. And high flow rates, they'll cause a lot of friction on the inside of the hose, which will lead to a breakdown of the tube and an eventual failure. But in addition to the inside diameter, you're also going to want to specify the length. And the length is important, as you're going to want to make sure you have enough length to accommodate any offsets or bends that you need to make. So if you look in this diagram down here, we show the overall length, which is typically from the end of one fitting to the end of the other fitting. but that can change depending on other fittings. But we also have the live length, which is the usable length of flexible hose that's in an assembly. And the live length is what's going to determine what kind of flexibility you have when installing and using an assembly. We can get pretty short live lengths, but when you get down to short live lengths, you really lose any type of flexibility or bending ability of the hose. You're not going to be able to take the get the same offsets that you would with a longer length of hose. And it's also important too, if length is important to fit into your application, that you take into consideration length tolerances. This chart shows NAHAD's standard length tolerances, which are based on inside diameter and length. These are standard. Some tighter tolerances are typically available, but it's definitely better to specify it at the beginning, as tighter tolerances are not always available just due to the method of manufacturing of assemblies. So next we come into temperature. So you're going to want to specify the temperature of the your process media, as well as any environmental temperature extremes you may run into. When we're dealing with industrial hose, there are many different blends of rubber available for industrial hose use, which are all rated to different temperature ratings. So for example, you may have a rubber steam hose that can handle steam up to 400 degrees Fahrenheit. Food and beverage hoses can typically handle well over 200 degrees Fahrenheit. But there are also some air and multi-purpose or even plastic industrial hoses that are only rated to about 180 to 200 degrees Fahrenheit at the very most. And this is important, as well as you can see here in the little breakdown that as temperature is going to increase, the rated working pressure of your hose assembly is going to decrease. So if you have a 300 psi rubber industrial hose spec'd in, but you're using it at 250 degrees Fahrenheit, your assembly is not going to be rated to 300 degrees Fahrenheit anymore. It's only going to be rated to half of that, or 150 psi. So if any temperature extremes are coming into play, very important to be for you to make your supplier aware of that. And in addition to just making the hose, make sure the hose works properly. If there's going to be any temperature extremes, we're going to want to make sure that you protect your operators from touching anything that may be high in temperature. And the picture to the right, for example, is a hose that would be seeing steam going through the inside. So to protect the operators from accidentally grabbing onto a hot hose, we've installed a fiberglass sleeve, which helps to insulate, keep the heat in while keeping the outside of that cover nice. I wouldn't say nice and cool, but definitely a much more manageable temperature. Next, for A, we have application. And application really just describes the conditions of use that the hose assembly will see. Some of the most important things to consider in terms of the application are any bend radius or flexibility requirements, since not all hoses are built to bend the same way or even have the same type of flexibility. It's going to be important to know any movements that are going to be occurring. Need to know the environment that it's going to be in. Is it going to be exposed to sunlight, any type of weather, or is it going to be inside in a climate controlled area or in near a furnace, say, where there's an elevated temperature? Is there any abrasion that could potentially affect the exterior of the hose? We see this a lot when a hose is installed in an application and it's either coming into contact with another hose that's moving, or the hose is moving and it's rubbing up against, say, another pipe or some sort of support. And it's also important to know if static buildup is going to be an issue, just due to the fact that any discharge of static electricity could cause harm to an operator, as well as even potentially start a fire if the process media is flammable. And it's a good idea when specifying the application. I mean, it's a really good idea just to provide as much information as possible. And this includes taking pictures, providing sketches if possible, as well as taking videos. And that's what we have here in this next slide. It was an example we had of a customer who kept having a hose failure occur in their application. Couldn't quite figure out why. On the left, you see how the hose is moving back and forth. And over on the right, we do have a picture of the hose taken out of service with you can see the hole in the cover exposing the tube and the reinforcement. So as the customer was describing this application to us, we couldn't quite figure out what was going wrong. But when he sent us this video, what we could tell is that the hose, its movement is going through 2 different planes. And what this does is cause a torsional stress on the hose, which will lead to failure. So some of the information that would have been useful from the front end would have been that description of movement, as well as the potential for abrasion, which you can see they already had some sort of cloth cover put on this braided hose assembly. But we did see quite a bit of abrasion happening on this yellow hose from the other braided hose assemblies that were moving right along with it. So next in the stamped acronym is the M for media or material. And this basically just is what's going through the hose. In the case of a chemical hose, as much information that can be provided about the chemical is going to be helpful, such as obviously the name, as well as the concentration and safety data sheets on the hose. Never hurt at all either. Really, as much information that can be provided is helpful. As an example here, you can see a chemical compatibility chart that came out of Continental's hose catalog. You have chemicals here on the left, and across the top, you have different blends of rubber that they use for their hoses, as well as some of the names of the hoses that are commonly used. But you can see for acetic acid, for example, there's different entries and different information for concentrated, dilute, glacial. So definitely concentration is important to know because we really need to check that compatibility against the tube material that's specified. And this is also a good time to let us know if there can be any special requirements that are needed, such as FDA or 3A approvals if this is a sanitary type of application, or API if that so applies. Just because not all food and beverage hoses are going to have the same approval, so definitely make that known at the time of specification here. Next, we come to pressure, and this refers to the process pressure that this assembly will be going into. But just besides the normal operating pressure, we're going to want to know if there's any potential for a pressure surge. If any type of pressure spike greater than the maximum working pressure of the hose will greatly shorten the hose life, and it's going to cause a premature failure. So if there's any potential for pressure surge, definitely make that known. If you need to handle a vacuum, not all hoses are going to be able to handle a vacuum. You're going to want to have a helical wire going through that hose. That's what gives it can give a hose a pressure, a vacuum carrying capability. Temperature, we touched on that earlier. Just because a hose is rated to 300 psi does not mean it's going to be rated to 300 psi overall temperatures. So if you are going to have an elevated temperature, make sure that you're speccing out a hose that's going to be able to meet your pressure requirements at that high temperature. And also, very important here to note that the pressure rating of a hose assembly is not always the max pressure rating of the hose. Almost all hoses will have a pressure rating that's printed right on the lay line of the hose. But once you put it into assembly, that pressure rating is not always the pressure rating of that assembly. You're going to want to make sure that the fittings and as well as the attachment method are able to handle elevated pressures as well. For example, we can have a 300 psi rated chemical hose, but we're putting a cam and groove fitting on there that's only rated to 250 psi. So even though the hose says it's 300 psi, that assembly as a finished system, its max pressure rating is only 250 psi. So you're always going to want to look for the lowest rated component. Next, we come to the ends, which are the end fittings. There are many different styles, materials that are available, but when choosing a style of end connection, whether it be cam and groove fitting, a flange, or threaded end, you're going to make sure it's suitable for the application. For example, cam and groove assemblies are not, or cam and groove fittings are not meant for use with compressible fluids. It's only meant for use with liquids and solids, non-compressible liquids rather. And you really want to take into consideration how frequently you're going to be connecting and disconnecting this attachment. If you're looking for a very secure attachment method to your process and that assembly is going to stay in there for an extended period amount of time, you may want to think about using a flanged end connection for a secure long-term connection. But if this is a process where the hose is going to be connected and disconnected many times throughout a shift, a cam and groove fitting might be more beneficial to you. But at the same time, you want to make sure that if this is a hazardous application, that you're not going to have a fitting that is going to be very easily disconnected. You may want to look, for example, for a cam and groove fitting in a chemical application. May want to consider using a locking cam lock or some other type of specialty chemical fitting, such as a dry disconnect that will prevent any type of catastrophic failure just in case of an accidental disconnection. For the material of the fitting, you want to make sure too that it's compatible with the media that's going to be going through it, as well as anything that could contact it from the exterior, from the environment. Say if there's some sort of acid or chemical that's going to be dripping on it from the outside that happens to be in the environment. Make sure that that fitting, that material is going to be compatible. And as we touched on before, the attachment method is going to be important in terms of the assembly's pressure rating. We see over here, we have crimp sleeves, crimp ferrules, as well as on the assemblies up here that use the ferrules. The crimp sleeve is just a cylindrical piece of metal that we can crimp down onto the hose. It gives a great amount of holding power to keep that fitting kept attached to the hose. But there are also crimp ferrules which have an additional lip which will fit into a special groove on the fittings just to give it that much more holding power. But over here on the left, you can see just a lay flat style water discharge hose assembly where they use band clamps. Now the band clamps aren't going to have the same type of holding power that a crimp sleeve or a crimp ferrule is going to have, but for an application where you're just trying to pump low pressure water from one area to another, it's going to do the job just fine. And then finally, we come to delivery, which can refer to how quickly the assembly is needed, but also what type of special requirements are there, such as testing, tagging, packaging, what type of documentation and traceability is needed. For example, we can get into hydrostatic test reports. We can tag a hose with whatever type of serial number or identifier that you may need, which we'll dig into here in just a couple of slides. But once you have the stamped information for what you need for a hose assembly, you're going to want to give that information to a qualified fabricator to make sure that you're getting a correctly designed, specified, and built assembly. So NAHAD that I mentioned earlier, the Association for Hose and Accessories Distribution, they're important. They provide performance standards for specification, design, fabrication of hose assemblies based on industry best practices. So they provide training as well as testing to hose fabricators to make sure that any type of hose assembly that is built is going to be safe. So one of the attachments that you'll see up in your control panel is a guide to evaluating a hose fabrication supplier. And it gives you a checklist on what to look for in a hose supplier to ensure that you're getting the safest hose assemblies that you can. And I just outlined some of the main points here. Is you're going to look for a fabricator whose personnel have been properly trained and tested, which, like I mentioned, NAHAD will do. They'll provide a certification stating that a fabricator has adequately passed the test to be a certified fabricator. You want to make sure that they're assembling all hoses in accordance with NAHAD standards. Make sure they have the ability to conduct any type of testing that you require. Make sure they have a company quality manual as well to make sure they are standing by their product and have effective means of verifying what they're going to be supplying. Make sure that they can use hose identification methods that's spelled out in the Hose Safety Institute handbook. And you'll want to see if they have any other additional industry certifications that may prove beneficial to you. For example, ISO 9001:2015. So now we're going to just dig into a little bit about what goes into the building of a hose assembly. In this most basic form, there are 6 basic steps. The first of which is to cut the bulk hose to length. So when doing this, you want to make sure you have a nice straight cut that's perpendicular to the hose axis. This ensures that when the hose, when the fitting is inserted into the hose, you have as much contact between the interior of the hose and the exterior of the hose shank as possible. They'll really give you as much holding power as possible. Next comes the insertion of the fitting into the hose, which having a large hose assembly can sometimes be quite tricky with inserting fittings. Typically, the hose shank on a fitting is a bit oversized as compared to the inside diameter of the hose tube, and this is to allow the shank to grip onto that tube. So it can be somewhat difficult to insert a fitting. So sometimes lubrication on the tube or shank or both is needed, but it's going to be important that during this process we don't modify the hose shank or the inner tube, and we want to make sure that we're not damaging the shank or the tube by any means, as that could pretty much eliminate any of its pressure carrying capabilities. You're going to make sure too as well that the fitting is installed to the complete and proper depth. Next comes the process of permanently attaching the fitting to the hose. So how that starts off with is our fabricator will measure the outside diameter of the hose. And from there, he's able to determine the correct sized sleeve or ferrule that is to be used on this assembly. With that information, he can calculate a diameter to which to crimp the ferrule or sleeve to ensure that we have a good solid connection. And once that's done, he's going to also as well verify that finished crimp diameter with a set of calibrated calipers to make sure that the settings in the machine are providing accurate and consistent results. So here we have a quick little video of a crimp being performed on an air and multi-purpose hose. So as you can see, the dies are coming down and squeezing that hose to the specified crimp diameter. It's held for 5 seconds until it is released, and then we have a finished crimp. So besides verifying the finished crimp diameter, we're going to want to make sure that this hose can actually hold pressure and is not going to leak. And to do that, we perform a hydrostatic test as a standard, although there are other types of testing available if needed, but hydrostatic testing is definitely the most common for industrial hose assemblies. And how this works is water is fed into the assembly from here on the bottom of the picture. And this tank is actually at an incline, so the fitting at the far end is actually slightly elevated from the bottom. And what this does is make sure that as this assembly fills with water from the bottom, any air is pushed out. So once this hose is completely filled with water and all air is expelled, the hose is pressurized to 1.5 times the rated working pressure of the assembly. And the importance of getting the air out of that assembly is that we want to test using only incompressible media. So in the case of a hose failure, using an incompressible fluid like water, if there is a failure, there's a quick discharge of pressure, but there's not a lot of energy stored in that assembly. So any type of failure, the energy that's going to be transmitted out is going to be minimal. However, if you're using high pressure air, there'll be an immense amount of energy stored in that hose. So if a failure occurs, there's a much larger chance for a catastrophic failure. So while this hose is pressurized with water, we're going to be holding it to its pressure for 5 minutes, during which time the hose is going to be inspected for any type of leaking, any type of deformation, as well as any type of slippage from the coupling. It's actually pretty impressive to see some of these large hoses tested. As they begin to be pressurized, you'll actually see the assembly grow in length. It really is quite impressive. And that leads us into our next poll question here, I believe, Dan.
Yes, I will get that launched right now. Okay, so you'll see the next poll on the screen right now. Hopefully you can participate in this one. So based on some of the knowledge that Austin has given us over the last few slides, we wanted to see, get your guys' opinion on what you think. The answer to this question is, so when hydro testing a hose assembly, what should you base the test pressure on? So in that last slide, he mentioned 1.5 times the working pressure of the assembly. So which of these should be what we're basing that 1.5 times pressure on? The rated listing on the hose, the lowest rated component of the assembly, or the pressure at which you intend to use the assembly. So we'll leave that run for a couple more seconds here. Looks like a good handful of you guys have voted already. Again, hopefully some of that knowledge that Austin has imparted on us over the last few slides will give the answers to these questions. So I'll let this run for just a couple more seconds here as some more responses are trickling in. All right, I'm going to close it down now and then share the results here. So as you can see, the correct answer, Austin, you can confirm, looks like the majority of our participants correctly found that the pressure of the hose assembly or the hydro test should be based on the lowest rated component of the assembly. So
yeah, that is correct.
Nice job, Austin, and nice job everyone who participated.
All right, so once testing has taken place, when we have a finished hose assembly that we know is going to work, the next step is to provide any type of documentation or identification to help with the traceability of this assembly. So as what we do in-house, we actually have an etching machine, which I'll share this quick little video. So we have the ability to permanently etch a ferrule with any type of serial number, part number, code, whatever you may need or want. We have the ability to etch that permanently onto the hose. And this really allows us to, in the off chance that you do experience a hose failure, that you can identify where this hose came from. And in our case, we have the ability in our ERP system to be able to track this hose assembly from the raw materials coming in down to who assembled the hose, who provided the testing, who did the crimping. So we really have the ability to track this hose right from the start, just in the off chance that there is a failure. So in addition to having the identification, the traceability, we also can provide documentation. We have an example here of our hydrostatic test report. At a minimum, you want to make sure at least that your PO number is included on there, as well as Peerless's either sales order number, job number, description of the assembly, so you can make sure that the document is corresponding to the correct assembly. We'll have our test pressure as well as the duration listed on there. And we want to make sure too that the test report includes information about the calibrated and serialized instrumentation that's being used to perform the test, to make sure that the pressure and the duration is provided is accurate. But in addition to pressure testing certificates, we also have the ability, if needed, to provide a certificate of conformance or MTRs if that is so needed. So once you have your assembly, you're going to make sure that you're following the best practice for storage, because the proper storage will maximize the lifespan of that hose assembly. So in general, you're going to want to protect this assembly from humidity, any type of temperature extremes, sunlight, overbending, or really any type of atmosphere that's going to degrade the hose. And once a hose has been used, If you're going to use it intermittently, before you put it back into storage, you want to make sure it's flushed and drained. So you're getting rid of any type of processed media that could potentially cause an issue if it's sitting in the hose for an extended period of time. And you're also going to want to keep the assemblies dry and off the ground, just to keep them in the best condition that you possibly can. So in terms of installation and the handling of assemblies, there are a few main points that we see tend to cause a lot of issues. The first being overbending, especially near the fittings. This definitely can cause damage to the hose tube or the hose reinforcement, which is going to limit its pressure carrying capability. So you're going to make sure when you're specifying a hose for an application that you allow plenty of room for the assembly to make nice, gentle bends. Also, what we see is people using hoses as an application where twisting takes place. And twisting or torsion is really something to be avoided when it comes to industrial hose, as hoses are not meant to withstand those types of forces. And you want to make sure you're going to avoid twisting both during installation and during the hose's actual use once it's put into process. And the other factor we see quite a bit is external abrasion, where we have a hose that's rubbing against another hose or a pipe or some other support that over time is going to wear away at the hose cover, wear away at the reinforcement, and cause a failure. So you want to make sure that you either have some sort of abrasion resistant cover, or you reroute some hoses to make sure that there's no potential for external abrasion. Some of the most common solutions for these issues are hose supports, which you can see in this bottom picture. And these hose saddles are nice. They provide a large surface area, large contact area against the hose. So they really help to prevent abrasion to the tube cover that you might see if they were just using a single rope or some thin support. Hose reels are handy as well. They make sure that the hoses are stored at a bend radius that doesn't exceed the minimum bend radius of the hose that could cause damage. Also keeps them clean and out of the way. Swivel joints are something to consider if you're concerned with twisting or torsional forces. They'll help to relieve those forces before they're able to damage the hose. And as I just mentioned, a protective cover, whether it be for abrasion or even a cover that acts as a bend restrictor to prevent any type of overbending. So once an assembly is into place, in terms of maintenance, it's a good idea to perform a visual inspection at least once daily. Due to the unique nature and just sheer amount of variables involved with any type of hose application, it's near impossible to predict an accurate lifespan, which is why having an inspection plan is just going to be of the utmost importance. So from NAHAD's recommendation, it really is suggested that a visual inspection takes place before each shift or at least once a day. And some of the most important things to look for are any evidence of leaks. And really, you're just going to look at the general appearance of the hose. How does it look? Do you have any bulges behind the couplings? Are the couplings cracked? Do you have exposed reinforcement? This picture here, you can see there's some sort of abrasion that wore away at the cover and it actually wore into some of the reinforcement. So that hose has lost quite a bit of pressure carrying capability and is due to fail at any moment. Over here on the right, you can see this hose has a metal helix that has poked through the cover. And along here at the bottom, you can see some bulging coming out of from the hose cover, which is typically indicates either overbending or a process media coming between the hose tube and the hose cover. But either way, in these three examples, a failure has already occurred or is imminent. And as a rule of thumb, when in doubt, remove the hose from service. If you're not sure, it's better to take out a hose and have it inspected by somebody than it is to risk a potentially catastrophic failure. So in addition to a visual inspection, it's also recommended to perform periodic pressure testing on your assemblies. Not really a ton of guidance on how often to perform a pressure test, but really you should base it on your application, as well as the risk of failure and what could happen if a failure does occur. So typically we do see customers asking us to pressure test and recertify their assemblies, typically about once a year. But it's important to note that this should not take the place of a visual inspection. When we are testing used assemblies, we're using the same procedure as we would for a new assembly. We're testing it to the 1.5 times the assembly rated working pressure. And we're just going to look for any types of leaks, any type of coupling slippage, anything that is looking like we're going to have a failure. The reason a pressure test is important, here on the bottom we have a picture, an example of a thermoplastic hose that had a small pinhole right in the corrugation here, and this was about a 20-foot long hose assembly. So this was not something that was easily visible during a visual inspection. So as soon as we pressurized it, it immediately began spurting water out. So it's better to have a hose failure when it's filled with water rather than a hazardous chemical. And when we do this pressure testing, we can also provide another test certificate saying that this hose was once again tested and proven to meet working requirements. Finally, we'll come into some of the common failure modes that we see. The most common reasons for failure include the hose going to an improper application, whether it be it's going into a pressure that's too high, temperature that's too high, or even possibly too low, or the hose was not specified properly to be compatible with the media that will be going through it. Next is we see a lot of hoses that are going into an improper installation or were improperly assembled. So we want to make sure too that the fittings specified are correct for the application. Not going to want to use a locking cam lock, just any cam lock in general, cam and groove fitting for a steam application, as any type of accidental disconnection could be catastrophic. And then poor routing, which we could see either overbending or even abrasion. Typically, you want to make sure that, as I mentioned before, we have nice gentle bends, and the hose is not going to be rubbing against anything else. Which leads us to the next point too, is external abrasion or corrosion is pretty common as well. So even though the media going through the hose may be compatible with the hose tube, you want to make sure that anything that might come in contact with the exterior of the hose is compatible with the cover or the hose fitting as well. So to bring it back to what Greg had his story earlier, after reviewing the description of what had happened and the pictures, we had a few different procedures put into place that we did to help this specific customer out with this specific application. The first was to use crimp ferrules in the place of the crimp sleeves that we had seen had been originally used on this assembly that they had purchased elsewhere. And that ferrule really gave us the ability to increase the holding power onto that, the holding power of the fitting onto the hose. So we wouldn't have the risk of the hose sliding right off the fitting. And to ensure that we're getting a good crimp, our fabricator calculates the crimp specification that's provided by a formula that's provided by the manufacturer. For this facility now, any hose assembly that we provide is pressure tested hydrostatically to that 1.5 times max working pressure before it is shipped. And we also etch every weld ferrule with a unique job number and serial number and a part number to ensure that if another hose failure were to occur, we can look back in our system and check back to see where this possibly where it went wrong. So to wrap things up here, as mentioned especially by Greg's story, the consequences of hose failures can be quite serious, between accidents which lead to injury, damage to the environment, any type of OSHA fines, lost employee time, or potential lawsuits. It could be potentially catastrophic. And what we tend to see in people's way of thinking is that what they'll do is they'll use inexpensive hoses to connect the more expensive components of application equipment into a system. But really, hoses, fittings, clamps, hose assemblies should be purchased, inspected, and specified with the same care that is used for more expensive equipment such as sensors, instrumentation, nozzles, and pumps. And it's really, really important to make sure that a special hose maintenance program and procedure is in place, which I believe is spelled out a little bit more once again in the handouts that are provided. But that about does it. If there's any questions, please feel free to type them in. I believe we're going to be sticking around here just for a couple more moments here, so there is still time.
Yes, thank you, Austin. There is still time. I'm going to hand this back over to Kevin Quick, who's going to, I guess, wrap us up with a couple of slides. But yes, a reminder to please do ask a question if you have it, and feel free to follow up with us outside of the webinar as well. So yes, thanks, Kev.
Yeah, thanks, Austin. Really appreciate the information. It was a bunch there, and we really talk about this concept of where people meet pipe. And naturally, it's a dangerous place to be. And when you have the combined effects of movements, temperatures, pressures, and various medias, it can be catastrophic. Best case scenarios, there's lost time, downtime. Worst case, naturally, is what it can do to our people. So certainly an important topic. We did mention, application specific, and we did get involved in another application specific event with a tire company, and we were able to look at the pre-existing hose and make improvements on it, and it was, by all accounts, it was a win-win. So that case study is on our website. Also, just to remind you, we do have a certificate of completion available. Should you wish for one, just let us know when you get the email for the survey. And then next week's topic is a bit different. It's really focused on kitting and how various forms of kitting might look in your industry, some methods, best practices, workflow improvements, driving efficiencies, and eliminating waste. We do a great deal of kitting here, and we'd like to think we've learned a little bit about it over the years. So we're happy to share a little bit more about it with you. So once again, hope you have a great week. We appreciate your attendance, and once again, happy Veterans Day to anyone out there that has served. So thank you. This wraps it up. Thanks again, Austin. Great job, and we'll see you all next week. Bye now.
Thank you, everyone.